Good afternoon all. Now let us discuss about the case study of applications of digital signal processing for ECG signal analysis in heart disease diagnosis. See, digital signal processing is a branch of signal processing that deals with only the manipulation of digital signals. See, digital signals are used to analyze, extract and modify the useful information. See, digital signal processings are used in telecommunications, audio and video processing, biomedical engineering. Let us discuss about the application of digital signal processing for ECG signal analysis for heart disease diagnosis.
In the biomedical domain, analysis of electrocardiogram signal are otherwise known as ECG signals using DSP techniques or proven as to be a most efficient beneficial way, and the ECG provides a non-invasive way to the monitor to monitor the electrical way to check the heart and making it as a cardiac diagnosis, and with this requirements in the DSP and the DSP techniques, the extraction, the extraction, the classification of the signals of the classification of ECG signals done more efficiently, rapidly, and in the most cost efficient.
And here we get to know about the background of this study on digital signal processing in ECG signals for heart diseases. And so ECG signals are basically shows that how does the heart works by tracking its electrical activity over time. And it comes when we have to spot any heart issues like arrhythmias and heart attacks or even heart blocks. But here things come that when we track the heart works using electrodes, it comes along with lot of unwanted noise or interference. And the traditional system that just rely on or dig up with data very well. And so here when digital signal processing comes in, with the use of DSP, we can remove the unwanted noise or interference using this, and we can focus on the important parts like QRS complex and P waves and T waves, and even with the help of machine learning, we can help to detect the heart functions or conditions automatically. It basically makes the whole process more accurate and open up the doors for more cool stuffs like real-time monitoring or wearable devices.
Going to tell about the problem statement. So nothing but the accuracy of the ECG, which is highly depend upon the recording the signal. So there are some basic and common noise problem statement, which is nothing but power line interference, which inducing the nearby technologies or systems by the interference. And the second one is baseline wandering, which is nothing but the movement of the patient body. And the third is musical artifact. The electronic device which is kept near the heart is producing the musical artifact. And at the last is motion artifact, which is nothing but the poor connection between the skin and the electronic device of the ECG.
Here I'm going to say about the objective of DSP in ECG signal analysis for heart disease diagnosis. First, filtering. Filtering is about we have to design and apply the digital filters to suppress the unwanted and various forms of noises. Next is about feature extraction. Feature extraction is used to detect the relevant cardiac events such as QRS complexes, P and T waves, and time intervals. After that, the classification, it is used to first in classification we use the extracted features to classify the ECG signals in the patient's heart to detect whether it is normal or pathological conditions using the intelligent algorithms.
Methodology: data acquisition. ECG signals are collected using the biomedical sensors and the digitalized using the analog to digital converter. Sampling rate 250 to 500 is commonly used to capture the data volumes.
Here my topic is on tools and techniques. We use MATLAB and Python for to handle the signal processing unit. And here the hardware side is we worked with the DSP chips for the textile instrument sensors and processing to collect the ECG data to the ECG sensors and ADC modules. In the result session, we for the noise removal, we clean up with the baseline draft and the muscles noise, even the power interface, and it's throw the signal to the noise to the radio quite in bit. For the detecting the futures, the accuracy over the 98% of sensitivities, and the data overload to the largest is 90% of accuracy.
So advantages of ECG, high accurate, it is very high accurate. In real time, it has very more advantages, and flexibility, it is more flexible, and to be the algorithm is automatically, it is depends, and power efficiency, it is more storage power of this efficiency.
And after all this discussion and the points kept by you, we all came to know about what are the roles played by digital signal processing in ECG signal analysis. Let me conclude this by we all know that DSP has revolutionized the way ECG signals are analyzed. From removing the unwanted noise and filtering, it's been the long way to change it into real-time applications. And using the combinations of signal processing and machine learning techniques, we can improve more analysis and in the features like heart disease diagnosis and more in the medical applications.